Okay, friends, today this says exploring the effect of a, h, and k on the graph of y equals a x minus h squared plus k. If you're right with me, you're like, didn't we already do that? Did we do h and k? And we did a the day before? Yeah, but now we're just going to do them all together, if that's confusing. Now, if this a, h, and k stuff is all very confusing, well, that's why I'm with you for the first part of the investigation. Let's do the first row together and write down all the equations that I want you to graph. It says, what if a is 2, h is 1, and k is 2? Then my equation would be y equals 2. That's the a that you put out front. They said they want h of 1, so we go x minus 1, which that's the only really confusing part in this whole thing is why are they putting minus h? And I don't know if it's a good choice or not, to be honest. But the minus h there is to remind you that somehow the horizontal doesn't do what we expect it to do. You'd think positive would be right and negative would be left, and it doesn't work out that way. And we talked a little tiny bit about why that might be, but for now, you're supposed to be at the point where it's like, that's what it does. That's the end of the discussion. Well, no, that's not the end of the discussion. We're just nudging. And then this is plus 2. Okay, so that's what I'm going to ask you to graph on decimals. I'm going to do it on the screen too, so if you're watching this on a video, I'm going to do this on the screen as well, but I want you to have some independence. Really what I'm up to is I want you to get experience with using Desmos when you're in trouble and go, okay, let me try this on Desmos. So if you're sharing with somebody, great. Someone's trying out a graphing calculator today to see how that works. Okay, so next one. This is the second of 4. This one's also an a value of 2. But now the h is negative 1. So what goes in the brackets is actually positive 1. And if that seems weird, yeah. We don't know what to write. We're not very good at writing this and saying what's going on because it does the opposite of what most people's intuition would tell them. But that's an x plus 1 squared. Oops. And this one's also plus 2. And maybe before you graph it, you've already got a theory on what you're going to see. Good. This one, instead of 2 out front, it's negative 2 out front. But then we go back to x minus 1 squared plus 2. This is a very scientific, mathematical approach to things like, let's just change one thing at a time and see what happens. And when we're all done, hopefully we understand it perfectly. And the note goes so fast. The last one, yes, negative 2 out front. But now, change the h inside. So that's now a plus 1. And then minus 2 afterwards. Ooh, that one changes 2 at once. But hopefully that doesn't mess you up. Take a few minutes, go into Desmos. Graph, now do columns, right? Graph, and then try and answer all the questions from what you see. Then either turn that graph off and make a new one, or delete that graph and go again, and see how long it takes you. No rush, we got time. Go through this, even if you're working with a partner, and see what you discover. I'll keep chittering away over here for video people, or for anyone who doesn't have it on their screen. But you can mostly ignore me if you're doing this yourself in class, and I'll take up the answers in a bit. All I'm going to do for video people is bring up Desmos and type in the first one. Then I think you should do it on your own. Even if you're watching the video, you should try these on your own on Desmos. But I've already forgotten, so I got to go back. What was it? Y equals 2. Y equals 2 bracket x minus 1. And then there's a squared. There's lots of ways to do it, but the easiest to turn on this keyboard down here and then hit the squared button. I already forget. 2x minus 1 squared plus 2. And then you've got a nice graph. You can zoom in, really see the points. Maybe something like that really shows the points that you're after. I just rolled in and out with my mouse, but you can move around. You've got a touch screen or something like that. You can also change it up here in the settings if you want to change them manually, but most people want to do it on the screen somehow. But that's up to you. And then after you graph that one, fill in everything in that column. A few minutes to do that, even on the video, okay?
it's probably the wider deal. Oh, that's also like offset.
Oh, I'm seeing now. Maybe you want y equals x squared on there. So also the base graph y equals x squared. I've got the first two graphs on there. I put a y equals x squared, and then I put the first one up there. So you can see, now you can compare the two. I'm only looking over your shoulder so I know when to talk, okay, folks? So when I come by, I'm not checking on you. I'm seeing how far along everybody is so I know when to start taking them up. Number of zeros. How many times does it hit the x-axis?
Oh, wait, no.
2. Yeah, okay.
That's
All right. I like it. Remember, we're going to take them up, so you can take your best shot at this, and then when you take it up, hopefully that's the moment where you go, oh, I get that now. How are we doing? I see some blank spots. That's good. If you got some blank spots, you're like, I'm not sure what you mean there, then we'll take it up together. I encourage you to go down in columns. Once you get the graph on, then go straight down and answer all the questions as best you can. Those of you who are waiting for me, I'm going to switch the graph now on my screen. I'm going to turn that one off and put the next one on. How is it different? Y equals 2x plus 1 squared plus 2. There's blue and green if you're doing the second one. you're doing this on a video, you don't have decimals. Let me turn that one off and I'll do the next one. Negative 2x minus 1 squared plus 2. Oh, plus 2. Negative 2x minus 1 squared plus 2. So there it is, blue and dark blue. And then the last one, negative 2x plus 1 squared minus 2. Minus 2. Ooh, it's off the screen there. There it is. Okay. We getting there? We almost ready? I'm not rushing you, just checking. Already flipped over? Yeah. Okay. All right. Well, if you're not done, you can keep chipping away as I take some of these up. What was the first one? I think I've got them listed here. Notice with decimals, you can list as many graphs you want and just turn them on or off. So I'm going to turn off the last one and turn the first one on again. And then, is this going to let me move it around nicely? Yes. Okay. The blue is the original x squared graph. The red is the transformed graph, to use the fancy new terminology. And so let's talk about direction of opening. It was upwards, yeah. And hopefully you're getting a feel for why that's true. Or maybe you already knew going in that that a value decides. If it's positive, we go up. If it's negative, we go down. Width compared to x squared. I didn't find that easy. I had to really look at it for a minute to decide whether it was wider or less wide. But when I got to this version of it, I was able to tell. I was able to go, well, at this resolution, this one goes over 1, up 1 with 0.5s, whereas this one goes over 1, it doesn't go up 1. So this thing, it's thinner now. The red one's thinner. But that took a minute, though. So if it wasn't obvious when you looked at it, you really had to stare at the scale. And maybe this scale wasn't the greatest choice. Maybe with the scale I want's there. See? The blue one goes over 1, up 1. But the red one doesn't go over 1 by the time it's gone up 1. So it's a little bit thinner. Yeah? All right. Not perfectly clear, that one. But if we go to talk about vertical stretching, we talked about that with elastic bands. When you pull an elastic band upwards, it automatically gets thinner. So this thing has been vertically stretched. Vertically, if you talk about it vertically. I know you can look at it horizontally, but vertically it's been stretched upwards. Move left or right? Okay, I've already forgotten. The red had moved right 1. I'm going to put that in there too. Right 1, and this defeats intuition. This all would be very easy except for the horizontal. The horizontal, even though that's a -1 in the brackets, it's actually right 1. Moved up or down, I think it was up 2. That one's nice. We were happy about that one. That follows our intuition. A +2 on the outside, up 2, that's good. A vertex was at 1, 2. And maybe you're getting the feel that with this equation like this, we can just pick off the vertex very easily. And its axis of symmetry was at the x value of the vertex. X equals 1. And number of zeros, oh, I've forgotten. None. This thing never meets the x-axis. That's surprising. But now that we've seen it, hopefully it won't take us aback when it happens in the algebra. Coming up is some algebra on this, and we're going to go, oh, there's no answers. Hopefully this is like, oh, yeah, we can get no answers. We can get no zeros here. Did that help clarify what each of those things were asking? Hopefully the other ones are a little faster. We can do them a little faster, yes? Direction of opening of the second one? Up. It still was thinner. Its width was thinner because it was stretched upwards. Don't let those words confuse you. I know that is confusing, but all we're saying is the elastic band thing. When you stretch something up, it'll look thinner in this situation. Move left or right? The left one. And that's the only counterintuitive part. I was about to say the only difficult part. There's lots of difficult stuff here, but the only counterintuitive part is that right-left thing. So you got to watch out for that. And then this one was also moved up 2, so that didn't get changed. But it did change the vertex because it went left to -1, 2. And then the axis of symmetry was changed with that. I don't think, let me go back to my, still didn't have any zeros though, okay? And you might be starting to form a rule in your mind. If it opens upwards and it's been moved up, it's not going to have any zeros, okay? And that's a good rule, but I don't know that we're attached to that rule just yet. 0, zeros. Is it okay? What's different about this one? Not much. What did the negative out front do to this thing? Now instead of opening up, it opened down. And maybe you were less than blown away by that. Maybe you saw that coming. Maybe we've beat this to death now a little bit, have we? So this opens down, but it was still thinner. And again, you may have to look carefully to see that. And it's still stretched. And then when I look at my graph, I think it was right 1 up 2, right 1 up 2, right 1 again, giving a vertex of 1, 2. That made the axis of symmetry at x equals 1. Oh, but I forget now. Did it have zeros? 2 zeros this time. So we're finding out. A quadratic might have 0 zeros. It might have 2 zeros, but if you can you see the blue one? It's only got 1 zero. So that's going to be a mystery going forward. How many zeros do each of these things have? Anyways, this time we had 2 zeros. Okay, so this has now got less exciting as we go maybe. Last column, down, was still thinner, stretched vertically, but now with the +1 in there, that's left 1. What did the -2 do, though? Outside now? Down 2. That's the intuitive part. You'll like that part. You're like, okay, vertical, I'm good. Down 2 this time. And that meant with left 1 down 2, the vertex was at -1, 2. Yes, we're about to jump ahead and go, we can get that vertex just bang, just looking at it. Axis of symmetry, x equals -1 this time. And I already forget with the zeros, what happened with zeros. None again. So maybe this idea is starting to expand a little bit, is that if it's opening upwards and it's been moved up, no zeros. But it's opening downwards and it's moved down, we'll also get no zeros. -1, thank you, nice catch. I might have said -1 and then wrote +1, but maybe not. Either way, I wrote it wrong. Good catch. Any questions about that? Are the ideas starting to get, well, this is really a review of the previous 2 days, or putting the previous 2 days all together.
Is there ever a situation where it would be thicker in like the graph?
Yeah. If see these numbers up front, I use 2 every time because I was trying not to throw too many things at once. But if that multiplier up front was like 1/2 or something like that, you'd be horizontally compressed. That would make it look thicker. And this isn't a perfect example. You can think about if I stepped on an orange, it would get wider. Yeah, and that sort of gives you a thought process on that. Yes?
Wouldn't the vertex be
-1, -2? Good, another good catch there. I was moving too fast at the end there. The vertex was down 2, so -1, -2. Thank you. Other great questions? Those were 3 good ones. Okay, so I think for you, you can just flip the page to this note. And this note is, I'm just going to go over that stuff in technical format. If you got all that just happened there, then this is just saying the same thing in technical format. In the equation, y equals a x minus h squared. Again, you can look at that minus h and going, that minus h messes you up. The minus h is only there to remind you that the inside does the opposite of what you think it might do. So the constants A, H, and K have the following generic meanings. You can pick off the vertex. This is a nice study page right here. Yeah? When you're doing your homework, you can just break this page out. It's got everything all at once if you sort of follow what it's saying. The vertex, HK, you can pick off right out of there, but you got to change the sign of the one that's in the brackets. Yeah? Step pattern 1A, 3A, 5A. Axis symmetry is just X equals H, whatever number there is in the brackets. I don't get it from there, me personally. I like grabbing it right off the vertex there. That makes more sense to me, but you do you. And this K value is the easy part. If the K is bigger than 0, it goes up. If the K is less than 0, it goes down. Vertical stretch, if the A is greater than 1, it's a stretch. If the A is some kind of fraction between 0 and 1, like, let me just make a list there. If this is confusing, like this is like, if it's like 1/2 or 1/3 or 2/5, some fraction that makes it smaller, that's what we're talking about there. That'll be a compression. And then if the A happens to be negative, it flips it over. And then this is the one. Ooh, let me get out my red highlighter. Red highlighter. Danger. Danger. Maybe you're good. You're like, no, I get it. It's okay. But this is the dangerous part of this section right here, is that if the H is greater than 0, X minus H goes right. If it's less than 0, it goes left. If that's confusing, I encourage you to write this beside it. Is just put a simple example to help yourself. Just with the number 1 in there. With the +1 left. The -1 is right. Maybe that's more helpful than all the negative H's. H is greater than 0. You know, I'm not sure that is a great way to teach that. But the textbook does stuff like that. So I mentioned it here. I think this is better. What's here? It's like, let me just show me what it is. Positive means left for some reason. And I alluded to that with my Just Dance example. If I'm looking right at something, it makes it look like the dance has moved left. I don't expect that to be a perfect concept just yet, but that's a taste of why this one does the opposite. The algebraic version of that is, well, the H is on the same side as the X. The K isn't on the same side as the Y, so they would clearly do opposite things because they're not on the right sides, or not on the matching sides. Well, I don't know. Some people don't like screens like that. Some people are like, I was sort of understanding it until you'd put all the A's, H's, and K's. Now it just looks like alphabetics to me. So if you want to test yourself, here we go. Here it is all in a chart. Very unhappy with how this is fitting on my screen, so I'm just going to do a little playing around here. There, now I'm happy. And let's try and do this together, shall we? Y equals 2x squared plus 5. Is it a stretch or a compress? Stretch. Multiplying by 2 stretches things. It makes them bigger. So this is a stretch. Factor 2. Is there a reflection in the x-axis? That's the same as saying, that's just a fancy way of saying, is it up or down? Did it get reflected? No. This one's still upwards. It's still up. I'm just adding a few words in there to our interpretation. Horizontal or vertical translation. Did it get moved horizontally? Nothing in the brackets, no horizontal, but it did have a vertical, the plus k, so up 5. Saw a couple of frowns there, and that's okay, because I'm using maybe some slightly different words than I did in the previous screen here. Vertex, okay, if it's no horizontal translation, the vertex has stayed at 0. But there was a vertical translation, so this thing was moved up to 5. Don't panic till the table's over. When the table's over, you can decide whether it's making sense or not, okay? I'm going to try and cover a bunch of different examples in this table. And the axis of symmetry, like I said, I get it right off the vertex. The axis of symmetry goes right through the x value of the vertex. Let's do a harder one that will probably be easier for you. It's almost easier when all the numbers are there. Then if you had trouble with the first one, look back at it and see. Is it a stretch or compress? If I'm multiplying by 4, am I stretching it or compressing it? Does multiplying by 4, does that make numbers bigger or smaller? Bigger. So this is a stretch factor 4. Was there a reflection in the x-axis? Is this, yeah, it got flipped to down. That's what that is trying to say. Yes. But I'll put this word on there just in case you're like, well, why are you saying it like that? Reflection in the x-axis. Well, that's just a fancy way of saying opening up versus opening down. Okay. Horizontal or vertical translation. This one has both. What's the easy one? It's the easier one to pick off. Down 3. Everybody in all high school levels believes the vertical is easier to pick off. This is down 3. Then you go inside the brackets and you stop for a second. And most people do this. Can't see in the video, but I'm like, okay, plus 2. They first point right. They go, well, plus 2 would be that way, wouldn't it? But no, it's not. It's left. So it's left 2. I don't know. I don't know if you like the fancy study page, making your own up, or do something, but that's the one that's going to cause you headaches because it's the opposite of what you think, what your intuition tells you. But this, once I've got this, then I can get the vertex. Left 2, it's now at -2, the vertex. Down 3, it's down to -3, yes? So once you've got those transformations, those translations in this case, picking out the vertex, not too bad. And then finally, axis of symmetry will be, the axis of symmetry goes right through the x value of the vertex. Okay, let's do this last row and then we'll question. Oh, you're not question, answer, she says. Okay, I'm going to come right back to you. If you're confused about any of this, let's finish the last row because I think the last row covers some other things and you're like, oh, maybe I get all of it now. But maybe we got to pause for questions there. What were you going to say here? Compress. Factor 1/2. Because 1/2, when you multiply by 1/2, that makes things smaller. So that hopefully now maybe that a value makes a little more sense now. You're like, oh, when it's a number that, a multiple that makes things bigger, we stretch it. When it's a multiple that makes things smaller, that's a compress. This is the opposite of what people, if you asked grade 4 kids, does multiplication make numbers bigger or smaller? They'd say it makes it bigger. It always makes it bigger because they don't know about fractions and decimals very much yet. So that's if that's hitching in your brain a little bit, that's why. It's because you're used to multiplication making things bigger, but it doesn't if you're multiplying by small numbers. Numbers between 0 and 1. Okay, did this get reflected? Is it opening up or down? The 1/2 is still positive. So that's still opening upwards. So that means it hasn't been reflected. It's still pointing the same way as it was before. Okay, now this is where a giant click might happen where you go, oh, I get it now. Is this -4, is that going to affect the x horizontally? Or does it affect the y vertically? And how do you know? There's a little aha moment coming here about where these numbers are. Is this horizontal or vertical? It's horizontal, so this is, well, here I go. Look at, I still do it after all these years. I'm like, -4 in the brackets, left? No, right. Right 4. Now we're ready to make a rule. How do we tell which one's horizontal and vertical? Where's the horizontal one? It's in the brackets. Perfect phrase. The horizontal one you find in the brackets. Later, in later courses, we'll call it inside the function. But for now, we've only got one function, x squared, so we're not worried about that. But inside the brackets. And the vertical you found outside the brackets. That's why the first one didn't have a horizontal. It didn't have anything in the brackets. And so if it's just right for 0, because it hasn't been moved up or down, And so axis symmetry, x equals 4. Did it come full circle by the end of the table? You're like, okay, maybe I'm okay. But tell me what questions you have. I'm not trying to rush through it. This flip chart is, well, now we're asking for some cleverness to be able to tie this all together. Here's another version of the question. Write the equation that matches the description. We were doing write the description given the equation. Y equals x squared is reflected in the x-axis and translated 8 units right. Who wants a shot at this? Or at least part of it?
X plus 8, or y equals x plus 8.
Y equals plus 8. Oh, 8 units right. Ooh. So is 8 unit rights, is that in the brackets or out of the brackets? That's in the brackets. And it's minus 8. Boy, I don't know if you could hear everything he was saying up here, but it was the perfect thinking that you go through. Okay, is it plus 8 up front? No, it's even. Oh, no, not plus 8. Right is minus 8. That's what you'll go through. That's exactly the right thinking. There's more, though. I didn't mean to do that. There's more, though. What's the more? It needs 2 more things. Ellie? A negative 1, she said. Maybe you'll just put a negative. I don't know. You can do either one. It's not wrong. I think you'll see the textbook a lot of times just put negative out there. But like a lot of times with numbers, when we just put a negative out there, we mean negative 1. There's one more thing missing here, though. It's a squared, yeah. That's the function we're talking about. And as we get ready for grade 11, in grade 11, it'll be a different function we're talking about, but all the transformations will be the same. All the other stuff will be the same. Let's try another one. These aren't easy to think backwards. Compressed by 4, 2 units left, and translated 4 units up. Oh, some frowns. Here's some help. Oh no, he's all over it. I thought he was going to need, you guys would need help, but he didn't need help. Wham! He just wrote it down. I'm going to write down. He's already got it here. Let me just check it for him before I ask it for it. Yeah, he's all over it. So tell me what you got there. EC, tell me, what did you write?
Y equals 1/4.
Yeah.
Bracket x plus 2 plus squared.
He's all over it. Now let me just ask you about the 2. How did you know what sign to put on the 2? How do you remember it?
It's the opposite of whatever you think it is.
What's that?
It's the opposite of whatever you think it is.
He's going with opposite of everything it is. I like that way. Some other people might memorize. Positive left, negative right. They just might memorize that. I'll give you another way to do that if it's not clicking for you. Here's the non-clicky method. It says y equals x squared. Before you even read it, you go like this. Y equals, yes? And you just underline and you go, I need numbers in those 3 spots. That's what I'm looking for. By setting up the skeleton of it, it can really help your thinking. Because then you can do whichever order you want. Which of these 3 numbers is easiest to come up with? I really believe there's a right answer here. Yeah, the vertical translation I think is easiest one to come up with. So you just look and go, 8 units up. Stretch by factor 2, 5 units right. Ooh, which one's the next easiest? Factor 2, I think I agree with her, coming out with that vertical stretch, because it's just going to tell it to you. It's just going to say vertical stretch by factor 2. And then 5 units right. Minus 5. So maybe, hopefully, that h, that it being a negative h starts to make some kind of sense now. You're like, they're just trying to remind us. It goes the opposite. But I feel like there's something missing here. Did we forget something? The reflection. So that's not just a 2, it's a negative 2. So that skeleton method, I think, works very good, where you just write down the skeleton of what the equation is going to be, and then you just start thinking through what numbers are and where they go. I think that's the toughest version of the question. Words to equation, I think, is the toughest. Yeah? So I don't know what's coming next, but some other version where we go from this to this instead of from this to this, and just back and forth and around. Same knowledge, just used in another way. Do you need more time on that screen? I don't know what's going on. I did some awful copying here on this flip chart, so every screen I got to fix. Fortunately, I know just what to do. Describe the transformations. I think this is easier. That's what I think is easier. Here's how I ask it in grade 11 when we're doing the transformations with them. First, look at it and say, how many transformations has happened here? How many things have gone on here? 3. So we do it in point form in grade 11. So I give you permission to do these in point form. A couple little dots out there to say. So what do you want to do? Tell me. Which one's the easiest?
Stretch by factor 2.
I'm just going to add one word. Vertical stretch, factor 2. And you say, do I have to write that word? No, maybe not in grade 10, but you may as well get used to it. Because in grade 11, we'll see horizontal stretches as well in compression. So we may as well get used to it now. She picked off that one. She's going left to right, I think. Are you going left to right? Through the transformations? Yeah. She's got a different system than the easy to hard method that I suggested.
3 units, right?
Everybody's getting into this now. Let's just go straight across. 3 units. Right, let me check. -3. Right is +3. Oh, so right is -3. Yeah, okay. Yeah, and every time it's the opposite. And then the last one, I hope, is the easy one. Up 4. Okay, this one. How many transformations do you see this time? There's now 4 in this one. Let's not wait around till tonight to find out you don't have this down pat. Take a second and see if you can do that one. While you're doing that, I'm just going to peek ahead and see if my other screens are messed up, which they are. So I'm going to fix those up in preparation. You try that one. Oh, match the graph. Well, that'll be fun. And some graphing. Where's the homework? Is it down there somewhere? Oh, there it is. Match the graph and then graphing. Now I fixed both those. Now I'm ready. Who's like a rock star at this and can just name them off? We do this in grade 11 all the time. We just bang, bang, bang. GG, go. Reflect, pen, pen, pen. Reflected on the x-axis. You might see the textbook say in the x-axis, but on, I think, is a better word. Go, keep going. Vertical compression by 1/2. If you multiply things by 1/2, you make them smaller. Go, keep going. 5 units. I'm going to write the fancy words. You don't have to. I'm going to write the fancy words just in case the textbook does and you know, okay? Horizontal translation, 5 units left. That's how they'll write it. Do you have to write all that? No, I'll take left. I'll take 5 left. I'll take it. And what's the last one? 7 units down. Here's the fancy way. Vertical translation, 7 units down. Even on the test, you can write 5 left, 7 down. No problem. But I don't want you to leave here and the textbook starts using the fancy words and you're like, what are they talking about? The same thing, they're just using the fancy words. Yeah. 2 more pages? No, 2 more examples? Match the graph, always fun. And then actually, the culmination of everything we've been doing, let's actually graph some that we can do. All right, match the graph. Huh. Uh-huh. Which way do you like? Do you like to do them A, B, C, D, E? Okay, do green, orange, blue, red, purple? Or poaching, where you pick off the easy ones?
For A, it's the red.
A is the red one. She's so right. It's not red in your book, though, is it? You can't see the colors. So I'll just put A under that one in my green color there, okay? How did you know that was the one?
Because it's flipped. So then
We needed a flipped one.
so I got it to 3 at the top. And then I looked and saw that was moved 4.
Right 4, yeah.
And then that's how I picked it up.
Yeah. It was the only one right 4. You didn't even need the up 5, but it's a nice check, yeah. Okay, so then she wants to go A, B, C, D apparently. So who wants B? The what? I can't hear you. The blue one. I agree with her. How did you know? She looked for a down 5. You know what? I was making up your multiple choice quiz, your online quiz, and there's a whole bunch of questions I went, this question looks really hard. Except if you just look at one piece of evidence, lots of times you can just pick it off. So I think you'll find the multiple choice online quiz, there'll be a bunch of questions where you can just go wham, just like she did there. But it does match up. 5, vertical stretch. Left 1, down 5. Okay, so good. C. C is either the easiest one or the hardest one, depending on what's happening in your brain. Orange, I agree. How did you get there?
I saw the +6.
Saw the +6, left 6, bang. And there was no up, down. But those are the ones, surprisingly, those are the ones that mess people up sometimes when it doesn't have another number. And so maybe you write a +0 out there just to help your brain go, okay, hasn't moved up, down. D, what do you got? What's that? Green, gotta be. It's the only one left that's opening downwards. But let's just check. Was it left 8, up 1? Yes. Vertical stretch, yes. And so I guess this one's gotta be E. Does it match up? Right 7, up 3, vertical stretch. Yeah, that's the one. This is why we like matching, right? There's a lot of self-checking in there. Only problem with matching. Let me warn you about matching, friends. You never get one wrong in matching. Your wrong answers always go in 2s. Yeah? If you match up, so it's good matching when you see matching on tests, whether it's in my class or other people's classes. But you better double check because it costs you 2 marks every mistake, not 1. All right, here, this one. Here's what to do each time. When you want to graph them, first write down what the vertex is. Then write the step pattern. Those are the 2 pieces of information you need to graph parabolas quickly and easily. Which one's easier to get? The vertex. Well, she says the vertex now. Wow, we've changed. What is the vertex for this one? 6, -9. So if you know what you're doing, it's easily picked off from this vertex form. The one in the brackets changes sign. The one outside the brackets doesn't change sign. How about the step pattern? Normally 1A, 3A, 5A. So now it's going to be 3, 9, 15. And this is as easy as parabolas are to graph. Let me finish off the line of thinking that happened 2 chapters ago. We were trying to graph a parabola and we just subbed in all the x values and all the points. And everybody was like, ugh. I said, I've got a better way. It's going to take a little time to build it. Here's the better way. Drop on the vertex, which is 6, -9. 6, -9. And then use your graphing rule to gather points. Over 1, up 3. From there, over 1, up 9. 2, 4, 6, 9. And then over 1, up 15. That goes off the page. That's helpful to know, though. Then go right off the page. So then here, over 1, up 3. Over 1, up 9. And then carefully draw your parabola. And when you're doing these, to help the teachers marking it out, make those extra points extra big so they can see what you're using as your points. I'll do the second one in red. And then I'm finally done. Vertex step pattern.
Negative 5, 6.
Negative 5, 6. She's fast at those now. She's got a rule in her head, I think. Change the x, keep the y. I can only put that on if you want. Negative 5, 6. There. There's the vertex. Now the step pattern. It's always going to be 1a, 3a, 5a. But now, multiply those by negative 4, I get negative 4, negative 12, negative 20, which actually solves the up-down problem. By just multiplying it by that negative, it's automatically going to go downwards because you're going negatives. So from there, from that vertex down 4, 1, 2, 3, 4. Then from that point down another 12, which is all the way down to here. And then the matching points on the other side. Boy, that's thin. That's been really vertically stretched. So now it's a very thin graph. Ooh, I gotta be careful to get that to go through there smoothly. Some in your test stopped before the edge of the page. I encourage you to go to the edge of the page and put arrows on. I didn't take marks off for that. I'm not about to take marks off for communication, but that's what we're really looking for here, is a parabola that goes right to the edge of the page and has arrows in the end to say, the parabola keeps going from there. I'm just showing you this part of the graph. Have any questions there?